The previous example I used to demonstrate the geoarchaeological resource model was based on quite a simple example, the set of prograding beach ridges in Yemen. This comprised a geomorphological landform, which were recorded in the database, so there was only one type of feature to record, a landform. However, some sites are more complex than this and may include a mixture of sedimentary evidence as well as landform evidence. So what I'd like to do in the next example is to show you how you might record a more complex site, which is composed of multiple stratigraphic records as well as geomorphological evidence. For this, we'll use the site of Ras Ibn Hani in Syria, which has been subject to published work in a paper by Nick Mariner in 2012. What is really good about the geomorphological and geological evidence for this is it gives a really nice example of how we can use this evidence to show how the landscape around this archaeological site has changed in response to sea level rise. What is important about this site is you can see each of these red dots is a core site similar to this. So in total, there are 9 core sites. So we have 9 sites that show sedimentary evidence. In addition, offshore, this region over here is also covered by high resolution bathymetric data, and we can also see some landforms as well, such as this ridge and these channels. And these channels may be important because they were potentially created at times of lower sea level by rivers flowing from the land out to the sea to the coastline, which would have been located somewhere out here. So this site, therefore, we have 2 types of evidence to record, landform and geomorphological, and we also have multiple sample sites. In the case of the core records, we have 9 core samples to include. So how might we go about recording this? There are actually 2 options you could use. Firstly, you could record each sample site as a separate record, and then within the database, link them to each other using relationships. This would mean you would have 9 separate sedimentary records, so each core site would be recorded separately, and then you'd create a separate landform record to cover the channel, which you see on the bathymetry data. The alternative, option 2, would be to create a single summary record which covers all sites in the area. There's no right or wrong way of doing this. Option 1 is perhaps more thorough because you cover the you would describe in detail the types of evidence in each sample site, but it does mean it takes longer. Option 2 is more like a summary of all the data at this particular location and therefore can be done faster. So the choice of what you want to do depends on what you're trying to accomplish. Are you trying to create a very, very detailed record, or are you simply trying to create a summary which it gives a general indication of the geoarchaeological evidence? I'm going to demonstrate now, using this example, option 2. And the reasons for this is because it will show you again how you can include multiple terms and multiple feature types within a single geoarchaeological record. If we followed option 1, it would be similar to doing the previous example of the beach ridges, but just with a different type of evidence. So option 2 is I'm using option 2 just to show you a different way of recording. Okay, so we are now back in the database. For this example, I'm not going to show you in detail every single step. I'm only going to focus on the ones that relate to how we record these multiple terms and perhaps review specific things which are unique to the geoarchaeology resource model which you don't find in the heritage place one. So I've filled in my assessment summary already. I've started to fill in my resource summary, so I have my site name in here. I've added a short description. And I will now look at the process indicator, and I'll just take a quick look at this again because this again is a unique thing to the geoarchaeology. So what kind of processes or what kind of evidence in very general terms does this site give us? Firstly, it gives us an indication of sea level rise, so we can add that. We have a high certainty of sea level rise. We can also identify that there's a high potential for archaeological preservation. In one of the cores I showed you as an example, it has buried layers which are several meters below the ground surface, which contain organic remains. So within the bay, which is now covered by the sea, there is high potential for archaeological preservation buried beneath the bottom of the bay. But it's only been confirmed in one core, so I'm only going to use a possible certainty value for that because I'm less certain. What other things could we potentially add? We could certainly add, we can see that preservation of relic paleolandscape features. We have a channel on the seabed that is possibly evidence of a former river channel, so we can add that. And we also see in this case coastal retreat or erosion. We see that sea level has risen and the coastline has retreated back to its present day position. So you can see with sites with lots of different types of evidence and rich sedimentary and landform records, you can actually start to build up quite detailed pictures of types of environmental change and the significance of these for the preservation of the archaeological record. Now I've completed my resource summary, I can move on to the geometry and geography. To save a little bit of time, and because by this stage you should be familiar with how you enter records into the geometry card, I'm not going to get details of this. What I will show you though is that I've used a single polygon to cover all the sites, all the individual sample sites which I'm looking at. And this is because I'm following option 2 and creating a summary record which covers all the geoarchaeological evidence for this general area. My 9 core sites, which are located roughly here, and my landform evidence, which is located here. As I move on to the geography card, having entered the data for the country and the maritime region, in this case because I have evidence which is located offshore, which is located underwater, I'm entering data on the maritime region, in this case territorial waters. And finally, there is this field to fill in, which is unique to the geoarchaeological resource model, the overall location type. This gives you an indication of how you are defining the boundary of your data. Why am I putting the boundaries of my polygon where I've drawn them? In this case, because I have multiple scattered data sets within a small area, I'm not using the exact position of each data set. My core sites are located as individual points here, and my geomorphological landform feature, the channel, is located here. So in order to draw a polygon around them, I'm roughly interpolating the extent of my data. I'm basically saying all my data exists roughly in this particular area. So therefore I would choose interpolated boundary. If, for instance, I was using a following option 1 and creating a single record for each core site. So let's say I had a core site here and a single point representing that, I would choose data extent because that point would reflect purely the extent of my core sample site. In this case though, interpolated boundary is fine. And just to demonstrate, I've completed my environment assessment and I've added various things under each of these fields. So for topography, my site includes parts of a beach as well as a bay. So I've added those terms. In terms of a marine environment, I've added that it's moderately exposed. And I also included the wave climate and tidal energy. And I've entered data on my minimum and maximum depths or elevations as well. And you can see that here. In order to access that, for example, I could simply click on that text and change the values if I needed to. And now, having finished the environment assessment, we come to the geoarchaeology assessment, the main focus of the tutorial. So first of all, we set our certainty value. In this particular example, we have a very high certainty that we're dealing with good geoarchaeological evidence. So we can add that. And in terms of source of evidence, you've seen we have 2 different types here. We have evidence from cores. And if you wanted to link the cores directly to the publication from which the information comes from, you would be able to add it here, provided that that publication has been previously added as an information resource. In this case, it hasn't, so I will leave that blank. And the same is true of the bathymetric evidence. So you'll see if you scroll down, we have seafloor bathymetry as a category. So the seafloor bathymetry is where we get the information on the possible channel feature. So that can be added too. So you can see here again, we've entered multiple terms here to describe the two different sources of evidence we use for geoarchaeological purposes. In terms of a general date, we are working within the Holocene, and we're working actually based on the radiocarbon dates for this site, we're actually working across all three Holocene subperiods. So it would be okay in this case to simply click Holocene, and it's definite because there is radiocarbon dating evidence from this particular site. And we click here again to go back to the geoarchaeological evidence, or sorry, the geoarchaeology assessment card, and you can see my general date has been added now. If I wanted to enter numerical dates, in this case, I have radiocarbon dates, which are calibrated dates to before present, so BP. So my earliest date in this case is about 10,500 years BP, and my youngest date is about 2,300 years BP. So I would enter these into these two fields and then click Add. And now we come to the feature assessment where we'll actually add the information about our two different types of evidence. So remember, to enter the feature assessment, we first click Add, and then we click on the little line of blue text below to actually enter the feature assessment proper. So as I said, I'm following option 2. This is going to be a summary record, and I will enter both the sediment information from the cores, and I will enter the landform evidence from the seafloor bathymetry. So what I've done with this particular site is, because there is a series of 9 cores, each of which has its own stratigraphic sequence. What I've done beforehand is I've amalgamated these cores and created a rough summary of the stratigraphy of this particular site. And what I can see from the stratigraphy is it roughly corresponds to this sequence here. If we scroll up, where we initially start with a layer of peat at the very, very bottom, and we move into a layer of dark clays and silts, and then various layers of sand of different types, initially shelly sand, medium to coarse sand, and then fine or aeolian sand. It's quite nice because it's a nice simple sequence that we can then summarize and enter into the database. So now we've identified what the basic sedimentary sequence is for this site. We can see there are 5 units, 3 layers of sand, each slightly different, which sit above a layer of silt and then sits above a layer of peat. And we then go ahead and enter each one of these 5 units in one by one. It's worth noting at this point that there's no mechanism within the database for setting the order of these units, for specifying which one is the top unit and therefore the youngest, and which unit is the bottom and therefore the oldest. So our recommendation is to simply be consistent in the way you record. And when you record a sedimentary sequence, the first unit you should enter should be the top unit. And you move on to the second unit, which is then the layer below your top unit, and so on until the final the final sediment layer you enter is your bottom unit. Okay, so in this case I start with my first layer of sand. I scroll down until I identify sand, and I then identify the nature of the transition from this unit of sand to the one below. In this case I have a sharp or abrupt transition between the 2 sand units. How certain am I of this information? I am definite because it is recorded in a core which has been published. So I simply add that, and I have that unit there. And again, I'll repeat this with the next unit of sand. Again, there is an abrupt transition, and my evidence is definitive. And thus it is added it below. I repeat for the third unit of sand. Again, an abrupt transition, definite certainty. My next unit after the third unit of sand is silt, so in this case I would select mud, clay and silt. Again, there is an abrupt transition. We see the sediment types changing very quickly, and I'm definite about it. So as we'll see, there is our full sediment sequence being built up gradually below. And finally, we have at the bottom of our sediment sequence a layer of peat, which is organic material that is not fully decomposed. So you can classify that as organic sediment or deposit, an abrupt transition to the silts above, and definite certainty. Thus, we have been able to add a full sequence of sediment. The next step is to add our channel feature. So the channel is a landform. We're seeing the evidence in geomorphological terms, in terms of the shape of the Earth's surface, so therefore it is considered a landform. First, we select the landform type. In this case, this feature is a channel or gully. Remember, the landform type is descriptive, there's no interpretation. All we know from this is that it is a channel or a gully. We have identified one channel, and it would be considered isolated because we only have one. How certain are we? I would apply a high certainty. We're not definite in this case because there have been no detailed scientific scientific investigations of this feature. There's been no ground truthing, for instance. However, based on its morphology and position, there was a high certainty that that is what that feature is. Now we've added the evidence in terms of descriptive information for both the sediments and the landform. We can start to enter interpretation. And these interpretations relate to the total sum of the evidence because we're creating a summary record, so we add all the interpretations that derive from each of these features from both the cores and the landform evidence as well. So what can we see in this particular site? How can we interpret some of this evidence? Our landform, our channel or gully, is most likely interpreted as a river channel. And as you see, as you scroll through the interpretation types, you see they're organized in generic categories. So a river channel would obviously fall under the fluvial or alluvial category. River channel, wadi core. We add a certainty value. In this case, I would say high certainty because it seems to have features characteristic of a river channel, but I would not say definite because there have been no detailed scientific investigations of it. And then I would click add. Now from our sedimentary evidence, if you think back to the sediment sequence and interpretation I showed you earlier, you can see the transition from a sub-aerially exposed landscape to a lagoon and then to an open bay. So in this example, the peat layer would relate to the sub-aerial landscape, and if we scroll down, you'll see an organic category. And we could classify the peat in this case as a buried soil. I'm not assigning one of the other categories because in this example the publication does not go into detail about what plant species are in this peat, so we don't know whether it would fall into any one of these three more specific categories. So buried soil will do in this case, and I will assign it a high category, a high certainty, sorry. We can also see from the layer of sediment above the peat layer, and this layer is comprised of clay and silt, that this is a lagoon. So if we scroll down again to the list of marine and coastal features, we can see lagoon. Now in this case, I would give it definite certainty because this particular layer has had detailed scientific investigation, and that has been confirmed, that the sediment was deposited in a lagoonal setting. So we can click add. Other features you can identify. So this particular example, the lagoon that later transitioned into a bay. So we can then scroll down again to marine and coastal and identify bay and give it a definite interpretation again because this layer has a detailed scientific investigation. And then we click add. And that completes the geoarchaeology card for this particular site. If I wanted to relate it to another geoarchaeology feature, I could do so via this drop-down menu here, and provided another geoarchaeological feature had already been recorded. This completes this particular section of the tutorial. I hope by now you understand how it's feasible to add more complicated stratigraphic sequences and multiple records into a single geoarchaeological record. So hopefully you're by now aware that there's different strategies available for recording different kinds of geoarchaeological site, depending on the quantity and quality of the evidence that you have at hand and how you want to work with the evidence.